Welcome back. This is Mr. Greenstein's Geometry, and we're in Chapter 12. We're going to be talking about 12.1, the sample spaces and probability. A probability experiment. So anytime you do some kind of action or trial, we can get varying results on how it will turn out. So let's say that you're doing work for a drug company and you're testing out different drugs. So it could turn out that you have a good result. You come out with a drug that actually helps people. But there's also a possibility that when you're experimenting, you get into some danger and you blow up the lab. So there are possibilities that good things could happen or bad things could happen. And every one of these things is called an outcome. An outcome are the different things that could possibly happen when you do an experiment. So that's the outcomes, is the results of probability experiment. There's an event. An event is a collection of one or many outcomes, and the sample space is the set of all possible outcomes. So let's take an example of flipping a coin twice. If I flip a coin and it comes out heads, or it could come out tails in the first toss. Well, let's say it comes out heads, then we toss it again and it can come out heads or it can come out tails. If it goes heads and then heads again, we call that the outcome heads, heads. If it comes out heads and then tails, we call that heads, tails. Likewise, we have tail, heads, and tail, tail. So those are the four possible outcomes, and that's the sample space. We call this diagram a tree diagram. It kind of looks like a bushy tree, and we go down from each outcome to each next outcome. Let's use an experiment of rolling two six-sided dice. So what we'll do is we'll create a table, and it'll show all the possible outcomes. So I have possibility of getting a 1 and then a 1 and a 2, a 1 and a 3, and so forth, a 2 and then a 1, a 2 and 2, and so forth, all the way down until we get 6 and 6. And then we'll just sum those together and we'll just put them in this table here. An event is a set of outcomes. It could be one or more. Let's say that the event we want to express is the sum of dice is equal to 7. So we pick all the spaces here that have a sum of 7, and we call that an event. The probability of an event is a chance that the event will happen. So if I say use the letter A for the sum of dice equals 7, then I say the probability of A happening is this number out of the total sample space. The probability of an event could be from impossible, where there's a 0 chance of it happening, to it being certain, where it could be a 1 or 100%. Probability can be expressed as from 0 to 1. It can be expressed as a fraction from 0, 1/4, 1/2, 3/4 to 1. It could be expressed as a decimal, 0, 0.25, 0.5, 0.75, and 1, or a percentage, 0%, 25%, 50%, 75%, and 100%. Those are the different ways that we can express the probability, but it's always from 0 to 1. Most likely not impossible, most likely not certain, somewhere in between is more likely it would happen. Calculating probability, and this is theoretical probability, is the number of favorable outcomes and over the total number of outcomes. So a favorable outcome, let's just use the lottery. The favorable outcome would be that my number gets chosen, and I have 20 different, say, quick picks. So my numbers, my combination of numbers are the favorable outcomes. That's over the total number of outcomes. Well, the total number of outcomes are millions and billions. So even if I have 20 of quick picks, it pales in comparison to the huge number of outcomes down here. So my theoretical probability is probably going to be teeny tiny number. And we'll continue this in the next video.